Hello everyone, today we will be presenting our work titled Serve Towards Better Training of Deep Neural Networks using log-Softplus error activation functions. Activation functions are pointwise functions which introduce nonlinearity in neural networks. Choosing a suitable activation function for better training and improved efficiency has always been an interesting area of research. In the recent years, several activation functions were proposed. Here we chronologically provide a list of the most relevant ones along with our proposed. Existing activation functions such as sigma ReLU and leaky ReLU suffer from certain drawbacks, for example the dying ReLU problem and non-zero mean problem in case of ReLU and absence of lower boundedness in leaky ReLU. Considering the previously mentioned drawbacks, we have developed a novel activation function Serf, which has the properties as shown here. In particular, Serf has upper unboundedness and lower boundedness, preserves a small portion of negative information, it is smooth, differentiable, and has inherent preconditioning leading to strong regularization effects. In order to test the effectiveness of our proposed activation function Serf, we have considered these existing benchmark experiments and their associated datasets. In particular, we do image classification of Cypher 10, 100, and ImageNet, object detection on Pascal, VOC, and MS-COCO, semi-supervised node classification on Cora, Scicere, PubMed, machine translation on Multi30K, sentiment classification on IMDb, and PolEmo 2.0, and finally, multimodal entailment. We have used state-of-the-art architectures for the respective tasks. For image classification task in all three datasets, namely Cypher 10, 100, and ImageNet, we have obtained superior performance with respective state-of-the-art activation functions using the same architectures. This shows that our proposed Serf works well with small datasets such as Cypher and also with large datasets such as ImageNet. For object detection task, we have used YOLO v3 and Dino YOLO v3 architectures. We have evaluated Serf against leaky ReLU, which is intrinsic to the YOLO v3 framework. Mean average precision course clearly indicate that our proposed Serf outperforms the baseline leaky ReLU based architectures in the object detection task. For machine translation, we have used sequence-to-sequence transformer encoder decoder based on model trained on the multi-30K dataset for German to English translation. We have observed that Serf outperformed the remaining three activation functions as suggested by the blue scores. For sentiment classification, results suggest that proposed Serf outperforms the remaining activation functions. For the multimodal entailment task, we have used a smaller variant of the BERT model. The accuracy values suggest that Serf performs marginally better than GALU here. We conduct ablation studies on the MDIS dataset. We observed that noticeable differences in performance of Serf with respect to Swish and Mish for varied dense units, dropout rates, initializer, learning rates, and number of layers. When the number of dense units increases, the performance of the Serf becomes better as compared to Swish or Mish. Furthermore, as the number of dense layers increases, models becomes complex and optimization becomes difficult. The degradation in the performance for all three different activation functions confirms the aforementioned fact. However, Serf maintained a significantly higher accuracy as compared to Swish and Mish. We have also done ablations on Cypher 10 and one can find in the paper. Serf demonstrates properties such as upper unboundedness, lower boundedness, non-monotonicity, and smoothness, which are desired for an activation function. Experimental results with different state-of-the-art architectures on varied datasets for multiple tasks demonstrate that our proposed Serf outperforms baseline ReLU performance as well as other activation functions such as Swish, Mish, and GALU by a good margin. Future works include the understanding of the importance and contribution of preconditioner as a regularizer and how modifying it can have an impact on the final results. Probabilistic and parametric versions of Serf can also be introduced. Performance of Serf can also be explored in tasks such as image super resolution, image reconstruction, and so on. Thank you for taking the time to go through our work.